So we will be preparing for culture of Neisseria gonorrhea. We need two medias, GC agar base media that is for VC anti-supplemented chocolate agar media, and another one is only chocolate agar media. So today we are preparing the chocolate agar media with VC anti-supplement. It is especially for the growth of fastidious organism like Neisseria gonorrhea. So it is from high media, GC agar base. We need two major components. That is number one GC agar base from high media. Another one is hemoglobin powder from high media. So all the instruction of preparation it is written on the label. For making double strength, it is written clearly. 7.2 gram GC agar base has to be dissolved in 100 ml distilled water. So for single strength, it will become 3.6 gram in 100 ml. So now we are preparing for double strength media. So we will first measure the distilled water. For total volume we are making for 400 ml, 200 ml for GC agar base and 200 ml for hemoglobin powder. Ultimately, after preparation, after autoclaving, we will mix both these two components. So hemoglobin powder we have to prepare 2% in strength. Means for 100 ml, 2 gram hemoglobin powder has to be dissolved, and equally for 200 ml, 4 gram hemoglobin powder. So we'll starting the procedure, starting from the measuring distilled water and all this. Please have a look. Thank you. So this is the measuring cylinder. We are pouring distilled water here. So we need to measure 200 ml in each beaker, conical flask. We measure 200 ml. So this conical flux is for the GC agar base, that is to be measured 7.6 gram per 100 ml. That means now we have to measure is 14.4. For 100 ml 7.2. We are taking distilled water 400 ml. Again I have to 200 ml. That's why 14.4 gram we have to measure. And this conical flux is for the hemoglobin powder, that is for 4 gram in 200 ml. Now we are going to measure the media. So this is the
ওইটা তো ভুলে গেল কতদিনে কাটাই গেল
So this is agar base. We have measured 14.4 gram. It is done. same way we will measure 4 gram hemoglobin powder. Please stop putting 4 gram. Hemoglobin powder. So we'll be adding this hemoglobin powder into 200 ml of distilled water in a separate conical flask. So this is the water bath, already set in the temperature 56 degree. One thing I have messed up, this is the hemoglobin powder we have measured just now. So before going to autoclave, it should be mixed properly, otherwise clumping occurs. So to troubleshoot this problem, we have to put this conical flask in a water bath set in 56 degree for how long? 10 to 15 minutes to dissolve properly the powder. After that, we will autoclave this like this. Already 10 minutes over. Let's see if it's dissolved or not. Okay. So it seems to be dissolved. It's a clear even solution. So we are done with this. We are going to autoclave this all 3 parts. So let us see. So it is preheated to boil the water. Just boil this. This is the GC media base. Hemoglobin powder, and this one is SDA media. So I suggest to label properly while you are preparing multiple medias at a time. Label it properly. Because after autoclaving, the GC media and SD will be appearing as alike. Sometimes it is difficult to distinguish between which one is SDA or which one is GC.
মোৰ ডক্টৰ যি মোৰ চিষ্টাৰ মানে ইয়াত আছে আপুনি হেৰি চিনি পায় হেৰি যি হওক আপোনাৰ কাৰণে সুধিলোঁ মই এতিয়া কোনফালে যাম মই মেডিকেলত আহিলোঁ
Done. After reaching 121 degree, 15 minutes,
okay, ring me.
give a signal. So it is over the autoclave period. So we'll be taking out all this media. It's too hot. This one is GC agar. This is the hemoglobin powder in clear solution. It's well mixed and as well as sterilized. So we are taking out this from the autoclave. GC agar base media and hemoglobin powder. We will let it cool up to 50 degree. After that we will mix both the media and then we will have to add the VCNT supplement. As we are preparing the VCNT supplemented GC agar base, this is the VCNT. Came like this in lyophilized form from high media. So we have to reconstitute with 5 ml of distilled water in a single vial. This is the single vial. We have to add 5 ml distilled water through syringe. This is the distilled water. We will be adding with the help of the 5 ml syringe. So we are preparing first. So we have added 5 ml of distilled water. We have to mix it for a few seconds. Like this. So it is almost 50-degree temperature. This is the ambient temperature for mixing both two components, that is hemoglobin powder and GC agar base media. So first of all, open the plug. Then gently we have to pour the hemoglobin powder into the GC agar base by the side wall of this conical flask. Some of the flask containing hemoglobin mixture, few clumps may remain some them. That should not be added. Like these few clumps are remaining, so we are not adding this, the last part of this media. So after this, should be mixed with gentle agitation like this. Can mix in this way also. Okay, it's done. Now we will be adding the VCNT supplement. The VCNT supplement should be added 5 ml for 500 ml of total media. So our media volume is 400 ml. That's why we will be adding 4 ml of VCNT, the already reconstituted VCNT supplement, with the help of this syringe. Again mixed with gentle agitation. Now this is ready for pouring into the petri plates. So again 20 ml approximately to each well we are going to pour. Very clean area. Water there. one go you have to pour all this into it. Stop করে দিলে এটা হবে। So we have completed our procedure of media preparation. We have prepared two medias, that is GC Agar media with VCNT supplement as well as the SDA media. We have covered up all the procedure steps, starting from the measurement of the media up to the pouring into the Petri plates. So here we came to the end of this short video of media preparation. Thank you. And lastly, I have to conclude with this word that we'll let it cool down all this media for a few minutes. After that, we have to store it in a refrigerator. That means in a domestic refrigerator is 2 to 4 degree range, and all the plates should be placed as inverted, because otherwise due to the latent heat inside the media will result into the creating droplets into the cover of the Petri plates, and which may fall down into the media, and your whole media will be forced out. That's why. So we will be keeping into the fridge with a inverted method. It means this is the media, this is the plate, this is the plate. Here we have poured this media, and we will be keeping like this in an inversion. This is called inversion technique. So thank you.